Hello and welcome to this FMSP online revision session. This session is looking at the MEI Further Pure 1 specification and the topic of proof and algebra. We'll start by looking at the specification and seeing what you need to know. The first 2 points are general points and run throughout the specification. I've highlighted them here because they specifically relate to proof, but you won't find individual questions on them. There is often, though, an extra mark going for convincing argument in any show that question, and you will therefore need to be able to use these terms correctly. You need to know the difference between an equation and an identity, and again this won't be examined specifically, but there is an assumption that you know that an equation is something that you solve to find an unknown or unknowns, and an identity is something which is true for all possible values of an unknown. The remaining 3 points highlighted here will be assessed clearly and specifically, though, in individual questions, and that's what we're focusing on in this video. A few key points to start with. If you have a polynomial where the highest power of x is n, then it will have n roots, although some of those might be repeated. In the exam, generally at least one of the roots will be an integer, and the easiest way of finding that first root, and possibly the others as well, is by using the factor theorem. For questions about varying the roots, the best thing to do is to carefully learn the patterns. The sum of the roots is always minus b over a, where a is the coefficient of the highest power of x and b is the coefficient of the next power of x down, noting that that might be 0, there might be a missing power. After that, these little patterns alternate their signs as you move from left to right, so that by the time you get to the product of all the roots, it might be positive or negative. But if you remember that those patterns alternate their signs, then you will get that correct. Basically, you need to learn this page. Finally, for key points, do remember to put equals 0 on the end of your equation so that it is an equation and not simply an expression. You will lose a mark if you don't do this. Okay, let's have a look at some questions. Our first one simply says find the values of P, Q, R and S. So it's not a show that question, but there are 5 marks for it and only 4 values. So there will be some method marks, and in any case it's good practice to show clear working so that when you're checking your work you can make sure you've done it correct and you're less likely to make mistakes anyway. So here we go. The first thing to note is that when you do multiply this right hand expression out, the x cubed term will simply have the coefficient of q, which must therefore be equal to the 3 on the left hand side. So we can immediately write down that q equals 3 and use that in our further working to keep things simple. Now I do need to multiply out properly the right hand side. So keeping my work nice and clear, I will say that 3x cubed plus 18x squared plus px plus 31 is equal to, now x plus r all cubed, with the binomial expansion we know the coefficients are going to be 1, 3, 3 and 1, and multiplying that by q will give me coefficients of 3, 9, 9 and 1. So that's 3x cubed plus 9x squared r plus 9x r squared plus 3r cubed. And then don't forget the plus s on the end. We then need to equate the coefficients, and it's a good idea to write down that this is what you're doing so the examiner is very clear about it, and also so that when you come back to check you will remember what you were doing here. So the x squared term first, 18 must be equal to 9r, and therefore r is 2. Looking at the x terms, p must be equal to 9r squared, and we've just worked out that r is 2, so r squared is 4, so that makes 36. And then looking at the constant term, we have that 31 must be equal to 3r cubed plus s. R cubed is 8, 3 eighths is 24, so that's 24 plus s, and therefore s equals 7. Now we've clearly stated these through the question, but it doesn't do any harm to summarise these at the bottom so that the examiner can see clearly that you deserve all the marks. And we'll just have a quick look at the mark scheme to see how those marks are allocated. That Q that we observed at the beginning was just worth a B mark, no method mark, no working expected for that. There was a method mark for attempting to expand the right hand side and going on to attempt to equate the coefficients. And then there were accuracy marks for correctly identifying each of the remaining unknowns. Let's have a look at another question. This is about varying the roots. We're given the roots alpha, beta and gamma, and we're asked to find a new cubic equation with new roots which are related to the old ones. Again, it's a find question, not a show that question, but there are 7 marks and it would be foolish to try and do this without showing sufficient working. So I'll give myself a new page with a little bit more space. So the first thing to do is look at the original equation and write down the equations relating the roots. So the sum of the roots is minus b over a, always, for any order of equation. So that is minus 4 over 1, which is 4. The sum of the product pairs is the next coefficient divided by a, which in this case is 8 divided by 1 is 8. And the product is therefore minus the constant term over 1, so that's minus 3. I'm then going to give names to my new roots. Let the new roots be K, L and M, and then I can say that K plus L plus M, the sum of the new roots, is 2 alpha plus 2 beta plus 2 gamma, take away 3, so that's 2 lots of alpha plus beta plus gamma minus 3, which is 2 lots of 4 minus 3, which is 5. I then look at the product pairs, KL plus LM plus MK. So that's 2 alpha minus 1 times 2 beta minus 1 plus 2 beta minus 1 times 2 gamma minus 1 plus 2 gamma minus 1 times 2 alpha minus 1. That comes out to be 4 alpha beta minus 2 alpha minus 2 beta plus 1, plus 4 beta gamma minus 2 beta minus 2 gamma plus 1, plus 4 gamma alpha minus 2 gamma minus 2 alpha plus 1. Collecting similar things together, you can see that I've got 4 alpha betas, beta gammas and gamma alphas. And then I've got minus 2 alpha twice, minus 2 beta twice, and minus 2 gamma twice. So that's minus 4 lots of alpha plus beta plus gamma. And then I've got plus 3. So that's 4 lots of 8 minus 4 lots of 4 plus 3, which comes out to be 19. Then I'm going to look at the product of my new roots. That's 2 alpha minus 1 times 2 beta minus 1 times 2 gamma minus 1. I'll actually fit that in here so I don't run out of space on the slide. It's better to work down your page when you're not restricted for space. So that's 4 alpha beta minus 2 alpha minus 2 beta plus 1, all multiplied by 2 gamma minus 1. And that comes out to be 8 alpha beta gamma minus 4 alpha beta minus 4 alpha gamma plus 2 alpha minus 4 beta gamma plus 2 beta plus 2 gamma minus 1. And collecting similar things together as before, 8 alpha beta gamma minus 4 lots of alpha beta, alpha gamma and beta gamma plus 2 lots of alpha, 2 lots of beta and 2 lots of gamma minus 1. Okay, alpha beta gamma was minus 3, so that's 8 times minus 3 minus 4 lots of 8 plus 2 lots of 4 minus 1. That's minus 24 minus 32 plus 8 minus 1. So that comes out to be minus 49. And I've just got room to say that my new equation is I'm going to use a new letter, w cubed, minus that first coefficient, minus w squared, plus the second one, plus 19w, and minus the last one, so plus 49 equals 0. Let's just look and see how the mark scheme works for this. There is a method mark and then an accuracy mark for those first 3 equations relating the original roots. There is a method mark for attempting at least 2 of these 3 statements. There are then accuracy marks for each of these values and a final accuracy mark for putting them into the equation correctly at the end. Okay, one last question which is a little bit quicker than the previous one. This time our 3 roots are related to each other. They form in fact an arithmetic progression. We've got to find those roots and we've also got to find this value of k there. Okay, so the sum of the roots, alpha plus beta plus gamma, is a minus d plus a plus d. And that we can see from the equation is 12 over 4. So that gives us that 3a is equal to 3 and therefore that a is equal to 1. We're then going to jump to the end and look at the product of all 3 roots because that's actually going to be quite easy to work out. A minus d times a plus d. That is equal to 3 over 4. Now a minus d, a plus d, that's the difference of two squares, so a squared minus d squared, and we need to multiply those by a, so that gives me a cubed minus a d squared is 3/4. Now a we've already observed is 1, so 1 minus d squared is 3/4, and therefore d squared is 1/4 and d is plus or minus 1/2. Now it doesn't matter which one, because whichever one we take will end up with the same 3 roots, but possibly in a different order. So our roots are, if we take d to be 1/2, 1 minus 1/2 is 1/2, 1, and 1 plus 1/2 is 1 1/2, or 3/2. If we took d to be minus 1/2, we'd have got 1 take away minus 1/2, we'd have got 3/2, 1 and 1/2, and the order wasn't specified, so it doesn't matter which way round we give those. We haven't finished yet, we've still got to find k, and for that we'll need to use the product pairs. So alpha beta plus beta gamma plus gamma alpha is the product pairs, that's 1/2 plus 3/2 plus 3/4, and that equals 2 3/4, and therefore k/4 is equal to 2 3/4 is 11/4, and k is 11. Okay, we'll just look to see how the mark scheme works with this question. So there is a method mark for an attempt to use the sum of the roots, and an accuracy mark for finding that a was equal to 1. There's then a method mark for attempting to use the product of the roots, and an accuracy mark for finding d and then correctly getting all 3 roots. There is then finally a method mark for a valid attempt to use the sum of the product pairs, or to multiply out factors, or substitute in a root, various different ways that you could use to find k, and I've missed out the one there, a correct answer of k equals 11. Well, that's all you need to know for this topic. I look forward to your company in the other MEI FP1 videos, and wish you all the best with your exams. Goodbye.